Hello, Algebra 1 students. In this video, we're going to talk about compound inequalities. So by the end of the video, you should be able to solve and graph inequalities containing the word and, or. Compound inequality. So what exactly is it? It's a sentence with two inequality statements joined either by the word and or by the word or. When we have the word and, this means that you have both statements of the compound sentence sharing the same solution. So they're going to be true at the same time. These two inequalities, one came out to x is less than 4 and the other one's x is greater than -3. When you graph them, this is how you know for sure that they're an and compound. In between here, they share the same solutions. Okay. Another reason why I showed you how to do the set builder notation is for this exact reason. So you understand what all this mumble jumble means. Okay, the x, all real numbers of x such that -3 is less than x less than 4. Okay, now what if we have something with or? This indicates that as long as either statement is true, the entire compound sentence is true. It's the combination of the solution sets for the individual statements. So after these both were solved, you have one that says x is less than -9 and then x is greater than -5. What happens with the or statements is you got one will be running to the left and the other one will be running to the right. If you did it correctly, they'll always come out like that. All right, let's look at an example where we solve a compound inequality involving and. So what are the solutions of -3 is less than or equal to m minus 4 less than -1? We're going to graph the solutions. So anytime you see it in this format, it's always going to be and. Another indication is this right here. All inequalities that have the less than, when you have two of them, I should say, when you're comparing two of these, anytime they're less than, that should tell you it's going to be an and compound. Okay, so since m minus 4 is right between -3 and -1, we can join these two inequalities with and. So you're going to write the compound inequalities as two inequalities joined by the word and. If you're not sure what I mean by this, if you notice, we have this one right here matches this. Okay, all we did is I took this down and I made that an inequality of its own. And the other one, this one matches right here. Okay, so the next thing you'd want to do is just solve for the m by adding 4 to each side. Okay, so after we solve for that, we get 1 is less than or equal to m, and m is less than 3. Okay, we're going to write that solution as a single inequality. Okay, so this is our set builder notation. It's in that format. But I want you to look at this as being, yes, 1 is less than or equal to m, but that would mean that m is greater than or equal to 1. Okay, so we're going to want to graph this. So watch what happens when we graph this. So we're going to have the closed dot and the 1. We're not going to go to the left because technically 1 is less than m. So that means m is going to be greater than 1. And then the next one, we're going to have an open circle on the 3. We're going to go to the left. Okay, so there's our two inequalities graphed. But watch what happens when you put them together. There's this small little section here that they share solutions right in here. So this would be the solution to this inequality. All right, so the previous example I showed you how to solve this and inequality simply by separating. What I mean by that, separating them out into two separate inequalities. But right, you take that would be one inequality, and then this one would be your other inequality, and then you would separate them with the word and. I'm going to show you how you can do this without that. you can just save some time, because after all, especially when you're testing, time is of the essence. So I'm just going to use what I have here. In order for me to isolate this p, I know I have to get rid of the -7. I also have to undo the multiplication of the 4, one step at a time. So the first step I'm going to do, I'm going to get rid of that 7. I'm going to add that to both sides of these inequalities. Okay, so -11 plus 7 is going to give me -4. I'm going to bring down my symbol, less than. I'm going to bring down the 4p because these cancel each other out. I'm going to bring down the symbol again. 25 plus 7 is 32. Now, I still have to isolate that p. I have to undo the multiplication. I'm going to divide this by 4 as well as the other sides of the inequalities. So -4 divided by 4 is a -1 less than or equal, or so it's just less than, p less than or equal to 8. See, that was so much easier. Real quick and easy to get that set builder notation. The biggest thing right now is, how do you graph this? So the nice thing is you're working left to right. So on the left side, you're going to go to -1, which is, this is 0, this is -1. You're going to put an open circle because our symbol does not have a line under it. So it's going to be open circle. Then on the right side is going to be 8. So this is 6, 7, 8. We're going to put a closed circle because this one does have the line. Okay, and because it's an and statement, all the solutions, or what I should say is all the all the solutions will be shaded inside that -1 and the 8. Okay, so let's look at an example where we solve a compound inequality involving or. So we looked at the and statements. So what are the solutions of 3t plus 2 less than -7 or -4t plus 5 less than 1? So here's the difference. This is a lot different than and compound because it contains and or. This means it will not have solutions that overlap each other, right? They won't share. So all you want to do is first solve the 3t plus 2 less than -7. Okay, so we're going to subtract the 2 from both sides. We're going to have 3t less than -9. Then we're going to have to divide out by 3. Okay, so then this gives us t is less than -3. Now let's do the other one. -4t plus 5. We're going to subtract the 5s. That leaves us with -4t less than -4. And then we're going to have to divide that out by -4 on both sides. That gives us, oh, now look at this. Reverse the inequality symbol when you divide by a negative number. So watch what happens. Instead of it being less than, it's now greater than. Okay, so now the solutions are given by t is less than -3 or t is greater than 1. Notice that they're both going in opposite directions. This is how you know you got it right. So how do you graph it? So we're going to have an open circle in the -3. All our solutions are going to be to the left. And then you have an open circle on the 1, and all the solutions are on the right. Okay, so like I said, as long as you have both directions, you've got this direction and you've got this direction, and and there's the or, you did it right. Okay, well that was it for this video. I hope you all enjoyed and have a wonderful day.